So we are starting with using probability concepts in forecasting. So first of all, what is probability? Probability of an event E is equal to outcomes by total outcomes. It's not outcomes, outcome by total outcomes. So simple way. I'm not going into mathematical. If like event is nothing but when you do when you perform an experiment, the end result what you get is nothing but event. So when you toss a coin, the outcome is either head or tail, and the total outcomes is head and tail. That means head, tail, both can be the total outcomes. That means when you toss a coin, one side of the coin would fall, and the face what you see can be a head, and the total faces what a coin has is head plus tail. Correct or wrong? So can I say it is 1 by 2? Yes. So one outcome would be 1 and total outcomes is 2. This is the chance or probability. So when you toss a coin, the probability of getting a head is 50% and the probability of getting a tail is 50%. So 50-50 we say chances, probability. Okay. So we are using the probabilistic approach to forecast. So three methods of assigning probable values: classical method, like factually, then we have relative frequency method, and we have subjective method. So these are the three methods with which we would be assigning some probable values, or like some values which would occur in the future. We can assign probabilities to that. Suppose there is a train. I have to take a train. Sorry.
There is a discrete and continuous random variables also.
Madam, I'm coming to that. Like here.
No, in before that, before this one, sir. In the
No, don't worry. I will come to that. I'll explain while explaining. Don't worry. Like I'll explain what is discrete.
Okay, it's okay, sir.
Discrete means countable. Continuous means you can't count. How I will explain you with an open example. This is a probability distribution. 1, 2, 3, 4, 5, 6. 6 faces a particular die has. When you throw a die, what's the probability of getting 1? 1 by 6. What's the probability of getting 2? 1 by 6. What's the probability of getting 3? 1 by 6. What's the probability of getting 4? 1 by 6. Probability of 5? 1 by 6. Probability of 6? 1 by 6. So you know 1 by 6 is how much? 0.16. So if I say 0.05, 0.10, 0.15, 0.20. So 0.16 would be here. So I'll just write 1, 2, 3, 4, 5, 6. Can you count this, madam? Yes, we can count this. These are 6 bars, correct? This is discrete. That means you can count. You can count, correct? When I have to speak about continuous, suppose this is a normal distribution, and the average rainfall is like expected 2 mm, and 2.5, 3, 1.5, 1. So I say that the rainfall would be between 1.5 to 2.5. If I say like that, okay, if I say like that, it can take any value: 1.55, 1.5546, 1.5589, 2.11, 2.4568. It can take infinite values between this. Correct or wrong? Yes, am I right? Hello.
Yes, sir.
That is continuous. That means you cannot count. It will be going on like that. Okay, like this. When you see to a hospital, a heartbeat, it goes in this way. It is continuous. You can't. There's no. You can't count that. So if I write like this is discrete. You can count. Correct? Can you count it, madam? How many lines are there?
5.
One, two, three, four, five, six. But if I join like this, now can you count how many lines are there? No. It
No.
is it is continuous. Okay. That's good.
Okay.
Now, three methods here. Classical method assumes that each possible outcome has an equal probability of occurring. Yes, every outcome, like I told coin, head, the occurrence of head is 50%, the occurrence of tail is 50%. Correct? Factual information is available when you have some information with you that can be used to determine the probability that something will occur. The use of that information to assign probabilities is called relative frequency method. Yes. So you have some facts. Based upon that, you are able to conclude that, see, if I have some facts, like I have a fact, the railway station between Himayat Nagar and Kachiguda is like takes 20 minutes. Okay. Someone who starts, suppose a train is at 5 p.m. Someone who starts at 4 p.m. would has like caught that he was able to board the train 95% times. Okay. So with this, can I give a conclusion that if someone who starts before 1 hour can catch the train, and this is the probability or chances? Yes. Can I do that with, because I have a fact and data with me? Can I do that? Yes. Subjective method is used when neither the classical nor relative frequency methods can be used, because possible outcomes are not equally likely and relative frequency data are not available. That means you don't have a frequent data which is occurring frequently, and you don't have something like some chances that something can occur. So here what you have to do is you have to do you have to find out the probability based upon your beliefs. What you have to do, that means you have to apply your intuition. Okay, let's say this is Himat Nagar area, and there are two statisticians who want to who have been given a task of seeing that how many people in Himat Nagar are drunkards. Let's say, so Himat Nagar has 10 streets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, Himat Nagar has 50 streets. So 50 streets is a population, 10 streets is a sample. So what they are doing is they are going to every household and asking how many adults are there and how many people are drinking. And they got a data that like in this 10 streets, at least 60% of the people drink. With that, they drew a conclusion that at least between 60 to 70% of people drink in entire Himat Nagar. Okay. Hello. Hello.
Yes, sir. Yes, sir.
So they are, based upon their research, they are trying to draw a conclusion. That is like degree of belief. So this is used much in hypothesis testing. Null hypothesis and alternative hypothesis. You don't have all this, but it works there much more, this subjective method. So personally, you are trying to make out, like you are trying to do a survey and you are trying to assign probabilities. So here there is a frequency distribution, very simply understood. Number of sales, like 0 sales happen for 17 days. So 1 unit you sell like in some 23 days. Like there are some 23 days in a year whereby you have sold 1 unit. 29 days where you have sold 2 units. So like that, number of sales and the total number of days when the sales have happened accordingly based upon the units. Are you able to understand, madam? Hello.
Yes, sir.
Yeah. Now you can do one thing. You can find out the probability. How? You can take this and divide. This is the outcome, and the total outcomes is this. So is this nothing but probability? Yes.
sir.
Outcome by total outcomes. This is the probability. So you have this in front of you, and the sum of the probabilities is always equal to 1. Okay. So like based on the above probability distribution, the probability that digital age will sell no computers in given day is 6%. Yeah, 6% chances they won't sell any computer, and 10 computers like 3% chances. You can make out this one. Okay, based upon that you can just see how many days. Like 41% is like uh, that store will sell 4, 5, 6 computers. Add up this one, it gives you 41%. Okay, so this is what is the way you can draw your conclusions from this. You can go through that, then I'll go for the next one. If you have textbook, you can follow up the question. I'll just move to the next one.
Yes, sir. Completely. Sir.
Yeah. Okay. Now this was the probabilistic approach, and let's move forward now. So now we can see a graph here, and we can see the percentages. So zero sales,
Hello, sir.
yeah, madam. Actually, that book.
Yeah.
Hello. Yeah,
The
that
book
book
is not
actually
visible,
there
sir.
was some problem. Sorry, madam. Hello.
It is not visible, sir.
No, no, it's coming. It's coming.
Yeah.
Now it is visible.
Yes, sir. Visible, sir.
So now, yeah, okay. Now you can see the previous graph and number of sales and the probability we have made. So again here you can see number of sales and the probability. So zero sales 6% probability, like 1 unit sale 8% probability, and this is discrete. You can count this, correct? But if I make it like this, it becomes continuous. That's the only thing I wanted to explain. So based upon the graph, they have made a distribution. Now, expected value is nothing but average value, but with subjected to probability. So if I have to write expected value formula, pi xi. I can write that means p1 x1 plus p2 sigma pi xi, p2 x2. So when you add up all that, you get expected value. Okay. This is nothing but the probability into observation. We can definitely do that. So here it is number of sales, here it is probability. When you multiply the observation with probability, you get like expected value at the end. Correct? Correct? Or weighted average mean. So they have multiplied all the observations with the probabilities and they have got the expected value. You can do this, then I'll move forward. Yeah, finish madam, you should confirm. Hello.
Hello, sir.
Yeah, once done, please tell me now.
Yes, sir. Completed.
Okay. Okay, let's go. Now the next point is variance and standard deviation. That would make us to conclude this chapter. Then we will enter into the mainstream topic of budgeting, that is how to prepare all budgets. That would be the final topic to wind up this entire budgeting concepts. So now, like if I have to say, I take two stocks. That is like, now let us understand what is the meaning of standard deviation. Standard deviation is represented by the Greek letter psi, and this is a measure of risk. If you have seen my videos of risk like that, maybe I've shared the videos of cost of capital or CAPM model. I think if I've shared or not, I don't know. Like if I've shared, then you would have seen it's a measure of total risk. That is systematic risk and unsystematic risk. Okay. So now, so this is a measure of risk. In the sense, if I have to give you a small example, let's take this. So I have invested in a mutual fund. That mutual fund is has promised me to give a average or mean return of 10%. With a standard deviation of, like my consultant has said or my analyst has said that no, 10% is what they are offering. You can take a standard deviation of 2%. So the return can be 12% or 8%, anything. So this particular 2%, the difference between the mean, that is the average, or the deviation from the mean or average, is nothing but how much percent here? 2%. Can I say that is standard deviation? Yes. So how much away you are going from the mean is nothing but the standard deviation. The risk. Here you are getting 12%. Why? Because there is a more risk. Getting 8% because there is less risk. Okay. That is an understood fact. Can you follow? Hello. Hello.
Yes, sir. Yes, sir.
Yeah. Yeah, Zarina, are you
Yes.
following? Yeah, yeah,
Yes. Yes. Yes.
yeah. So this is a measurement of risk, but the problem with standard deviation is that it has a major problem. You cannot directly find this standard deviation. To find out the standard deviation, you should have variance. Again, variance is equal to chi square. So you can understand root of variance is standard deviation. Root of variance is standard deviation. Okay. But now you will be asking me a question. See, many of the books you will be reading that variance is also measure of volatility or risk, and standard deviation is also measure of volatility or risk. I'll give you the small difference in that, but let me first explain you why we cannot directly find standard deviation and why we have to find out the standard deviation via variance. See, this is observation X. 10, 20, 30, 40, 50. Average returns. These are the returns actually. Year 1, 2, 3, 4, 5. And okay, not returns, let's say marks. Marks. So what is the average of this? 90,
150.
120, 150 by 5 is 30. Understood, fine. So this is the average. Now, deviation from average, we have to see x minus x bar. That means how much this is away from average, how much this is away from average. So 10 minus 20 minus 10, 0, 10. When you see the sum of the deviations is always equal to 0. If I have to find out standard deviations, sigma x minus x bar by n, it is always equal to 0. I cannot find out. I can never find out, because it's a very important property of mean that sum of deviations is always equal to 0. So what I need to do, I need to square them to remove the negative and positive, remove the negative values. Now if you can total, it's 1000, correct? So sigma x minus x bar the whole square divided by n is nothing but variance. This is your variance, correct? Are you following? Please tell me.
Yes, sir.
Are you following? And root of
Yes.
variance, root of this is nothing but standard deviation. Okay, so why, since you cannot directly find out, you have to find out in this way. Now I was telling you now why we need to see this variance, and this is also a measure of volatility and this is also a measure of volatility, but why we need to find out this if this is there. See, this, if you speak about area, the volatility in the area can be measured in square meters, correct? Let's say the area of some grass lawn is 10 square meter with a deviation of 2 square meters. So this is a measure which is in square. So their variance comes into picture. If I have to see length, length is always in meters, not square meters. Suppose if I want to get a trouser stitched from a tailor, and the 10 meters is what they want the cloth, and the deviation of 2 meters. There can I use variance? No, I can only use standard deviation. Okay. So when it comes to square measures, variance is the measure of volatility. When it comes to normal measures, standard deviation is a measure of volatility. This is a crucial difference which you should know. They will be confused. They will be giving you such questions, thereby you will be confused and you will be putting answers without knowing like the concept deeply. So this you should understand. Okay, I'm giving you a question to solve. Please solve it. This chapter is done. Come on, finish this off. I'm waiting. Once done, please confirm me. Hello. Hello.
Hello, sir.
Yeah, once done, please confirm me.
Okay, sir.
Yeah, yeah.
Yes, sir, completed, sir.
Okay, okay. So we are done with all this. Tomorrow, today, I think we can start a new topic tomorrow afresh. And however, tomorrow I have no scope of taking a short class. However, it's a big topic and big unit. So we'll start tomorrow, and in 2 sessions, probably max to max 2 sessions or three sessions, I'll wind up this total budgeting. Okay. One is this chapter, then budgeting cycle. Yeah, where I have all the budgets. No, we'll do one thing. We will start with this chapter tomorrow instead of that chapter. This chapter from here. Develop annual profit plan and supporting schedule. From here we will start. Okay, because this would be better if we start from here. Okay, then tomorrow I'll wind up the next unit. What time shall we take tomorrow? Same time, evening 5 o'clock, 5:30. Like. Hello.
Five, okay, sir.
Okay. Okay, madam. Then just finish this probability approach. Tomorrow I'll wind up the next unit, next chapter, full fledged. Okay. Thank you.